I am Adithya Gopan from SNS College of Allied Health and Science. Today I am going to show the presentation about the case study of electrocardiogram. Electrocardiogram. Electrocardiogram is the graphic record of electrical activities of the heart obtained by placing electrode on the surface of the body that records the voltage differences generated by the heart. Electrocardiography, electrocardiograph and electrocardiogram. History. The word electrocardiogram is derived from the Greek meaning electro related to electrical activity, cardio heart and graph to write. Augustus Desire Valor 1856 to 1922. First to record electrical potential associated with beating heart from the human body surface. William Einthoven 1860 to 1927 invented string galvanometer in 1901. In 1924, he was awarded Nobel Prize for inventing the first practical system of electrocardiography. This is an early ECG device. Technical aspects. ECG leads. Direct leads and indirect leads. Indirect leads have three types: limb leads, chest leads, and esophageal leads. ECG leads. Limb leads, bipolar leads, and unipolar leads. Lies in frontal plane. Bipolar leads. Lead 1 between right arm negative and left arm positive. Lead 2 between right arm negative and left leg positive. Lead 3 between right arm negative and left leg positive. Next is Einthoven's law. If the electrical potential of any two of the three bipolar limb electrocardiography leads are known at any given instant, the third one can be determined mathematically by summing the first two. The positive and negative signs of the different leads must be observed when making this summation. According to Kirchhoff's law, L1 plus L2 plus L3 is equal to 0. Einthoven deliberately reversed L2 to get positive QRS deflection in all three leads. With Einthoven's system, Kirchhoff's law becomes L1 minus L2 is L2 plus L3 is equal to 0, or L1 plus L3 is equal to L2. Unipolar leads. Unipolar leads or Wilson leads, VR, VL and VF. Augmented limb leads, unipolar chest leads. Augmented limb leads, AVR, AVL and AVF. RA in different electrode LA and LF lead AVR. LA in different electrode RA and LF lead AVL. LF in different electrode RA and LA lead AVF. Unipolar chest leads or precordial leads lies in transverse planes or horizontal plane. Usually 6 standard chest leads are recorded. V1 fourth intercostal space to the right sternum. V2 the fourth intercostal space to the left sternum. V3 halfway between V2 and V4. V4 fifth intercostal space at mid-clavicular line. V5 halfway between V4 and V6. V6 fifth intercostal space at mid-axillary line. Special leads. V7 left fifth intercostal space on the posterior axillary line. V8 left fifth intercostal space on the posterior scapular line. V9 left intercostal space between the back of the left border of the spine. Right-sided ECG, V2 and V1 remain in the same place. V3R to V6 are placed on the same place as V3 to V6 but on the right side of the chest. Endocardiac leads. Normal electrocardiogram. PV. First positive deflection represent arterial depolarization. Normal duration 0.08 to 0.112 second. Amplitude 0.1 to 0.3 MV. Less height and dome shape. QRS complex consists of three waves Q, R and S represent ventricular depolarization. Normal duration 0.08 to 0.112 second. Amplitude 0.7 to 4 MV. Q wave. Initial negative deflection represents septal depolarization. Small downward sharp wave. Absent right ventricular lead. Present involved bipolar leads. R wave is a positive deflection in QRS complex. It's due to potential traveling of the apex of the ventricles. It's an upper bigger sharp wave. Peak of R wave is safest period as ventricles absolute refractory period. S wave is the second negative deflection in QRS complex. It is due to the potential traveling to the base of the ventricles. It's a small negative sharp wave. T wave is the positive wave following S wave. Represent ventricular repolarization is a dome-shaped positive wave for longer duration. Normal duration 0.27 second. Amplitude 0.15 to 0.5 MV. Isoelectric period. U wave is the final positive deflection. It's due to the slow repolarization of papillary muscles. Atrial repolarization. ECG segments. PR sequence. It denotes the time interval between completion of atrial depolarization and beginning of the ventricular depolarization. ST segment indicates completion of depolarization of the ventricles. Average duration is 0.05 seconds. J point is the point at which the S wave ends and ST segment begins. Ventricular depolarization ends and all parts of the ventricles are depolarization.